Okay, this question came up in the Maths 2022 paper, slope question. So there's a slope with an angle of alpha and tan alpha equals 3/4. So that's like your normal Pythagoras triangle where the hypotenuse is 5. Weight mass of 5 kg, external force of F, and a resistance to the plane or reaction to the plane, and then you've got a rough surface, you've got frictional force. And the question is asking to find out what is the frictional force and the value of F. Now I believe the value of R was 68.6 in this case. So what we're going to do is we're going to put all the forces in. So there's a force of the mass acting downwards of 5g, and we want to go along the plane and perpendicular. So let's put that in. Now the angle is alpha down at the bottom there, and along the plane is 5g sine alpha. Down the plane it's 5g cos alpha. Okay. Now, the next bit we're going to do is we're going to look at the other forces. So there's a frictional force. So again, perpendicular, it will be, we've got to put the angle in, which is alpha, because of its parallel to the one down below. So that's F sine alpha, right, cos somehow. So change that. So it's F sine alpha, and the one along the plane is F cos alpha. So that's going up. Okay. So, and then we know the reaction, and we know the downwards, the force acting in the opposite direction is 5g cos alpha and 5g sine alpha. And there's also the frictional force, which is mu r. Now, this can act in either direction depending on the movement of the object. It could be, if it's in equilibrium, it could be, it's basically stationary. But if it's moving up, the frictional force is down. If it's moving down, friction force is up. So be wary of that, especially in the second part of the question. So parallel to the slope, so we want to look at that, and that will help us calculate F. So R equals, what the force is down is F sine alpha and 5g cos alpha. Okay. Alright. Now, and then we know the value of sine alpha is 3/5 and cos alpha is 4/5. Okay. We also know R equals, so anyway, we'll put that in, but R is equal to 68.6 then later. So R equals 3f/5 plus 20g/5. Okay. Simplifying that, we get 5r equals 3f plus 20g. And then you can get f on its own, 5r minus 20g. Remember to put down r equals 68.6. Okay, so f equals 5r minus 20g over 3. Okay, and then you can plug in 68.6 using g of 9.8, and you'll get a value of 49 exactly. Okay, so that's F. Okay, now we're going to look at the forces along the plane, perpendicular to the plane. That was along, it was along the plane, what am I talking about? Along the plane. So now we need to look at the forces along the plane. So we've got the blue one, the green one, and the red one. Okay, so let's focus on those. So blue is 5G, so put mu r first. Thought I'd point this out again, can act up or down depending on the direction the mass is moving. This mass is at equilibrium, so if you put it down or up, it should work out. In one case it may be negative, in the other case it may be positive, so depending on which direction you've put the force. Some questions they come up and say it's about to slip down, in which case, you know, the friction force will be acting up against that slipping down. Okay, so just point that out, emphasize that. To go up, okay? And the second part of the question, you'll see why that's important. Okay, so now let's put the equation together. So F cos alpha, which is acting up the plane, equals forces down, which is mu r, plus 5g sine alpha. Okay. Now what we can do is put in the values for cos alpha and sine alpha. So 4f over 5 equals, put in the value for r, which is 68.6 mu, plus, actually you don't need to, if you're trying to work out the frictional force, you just say mu r plus 5g times 3 over 5, which gives you 3g. Okay? So then you've got mu r equals 4f over 5 minus 3g. Okay, and then you know what f is, it's 49. 4 times 49 over 5 minus 3g equals value of, calculating, taking a bit longer than I thought because it's a bit of a strange number that I'm getting. I think I'm getting 9.8, which is the same as G, which is interesting, but you know, just how it turns out, I guess. So I think that's what it is. It's 9.8 for mu r. And if you were to work out what mu is, you could work out what mu is because you know what R is at 68.6, and divide 9.8 by 68.6, you find it's 1/7. So it kind of depends what you need to do. Okay. Right, so mu r equals 9.8. Okay. So that is the first part of the question. Hope that made sense. We've got to, for f equals 49, mu r equals 9.8, and you know, I think the next part is going to be interesting because that is then asking about what happens when you remove the force. So in that case, the resistance will be moving upwards. So yeah, so we're going to get to that next. So I've just put down what mu r equals, and that equals 1/7. So, okay. Right, so thank you for that. Any comments, please leave them down below and move to the next section. Okay, so this is now, we're going to remove the force, and we're going to have the frictional force, or the mu, is going to change to 0.5. Okay, so let's just draw part of this again. We don't need the whole thing. And we need to find acceleration. Yeah, that's what it was. Yeah. Okay, so we've got alpha in there. We've got a 5 kg object there. Mu equals 0.5. So what's important here is that the resistance, the reaction, will obviously change because there's no external force. Therefore, R will actually get less. It's just going to be based on the mass of the object perpendicular to the plane. So let's put that in. So that's going to be, as you remember, 5g cos alpha into the plane. And you've got R, which is acting up. So basically R equals 5g cos alpha. So you need that to work out the frictional force. 5g cos alpha, as you know, is going to be 4g because it's cos alpha is 4/5. Okay. So the next part to this is to look at the forces along the plane. So it's easier because you've just got the frictional force and the one with the mass moving down. So the frictional force is going to be mu r, in which case it'll be 2g, so 0.5 times 4g is 2g. Net force, therefore, will be 5g sine alpha, which is along the plane, acting down along the plane, minus 2g. Okay, so that's the net force. Let's write that out. 3g minus 2g equals g. Okay. And then that equals ma, for f equals ma. So g equals 5a, a equals g over 5. And that's it. That's the question. Hope that helps, guys. Take care. Be safe.